Hey students, thank you for visiting me. I am Professor Bade. Today we are going to study construction of the curve involute. Be ready with your drawing instruments and sketchbook. You will able to get maximum from this video if you actually construct the curve with me. In this video we are going to solve 3 problems on involute. So what exactly the curve involute is? It is path traced by a point on a line rolling without slipping on the circumference of a fixed circle. If you remember in earlier video on curves, we studied construction of a cycloid. In case of a cycloid, circle rolls and line remains fixed. In case of an involute, it's exactly opposite. Here line rolls and circle is fixed. Now let's try to visualize a line rolling on fixed circle. Now watch here. Here is a circle and line AB. At this position, line AB is tangent to the circle at point A. The circle is fixed and the line rolls. Now let's visualize rolling of the line. So this is how the line rolls. Watch here, end A moves away from the circle. At the same time, end B moves closer to the circle. So this is how point A moves away from the circle along this path, and path traced by point B is an involute. Path traced by point A is an involute. AB is the initial position of the line. If this line continues to roll on the circle, finally end B comes in contact with the circle. So this is fixed circle. Now one more example, let's check. Here is a disc which is fixed. Here it is a line AB, you can see on the screen, but it is not line AB or it is not a rod, it is a string, a wire, a flexible thing. And its end A is in contact with the rim of the disc. As the end B moves in anticlockwise direction, you can visualize that wire AB winds over the circle. So during this winding action, path traced by end B, and try to understand, in this case it is flexible thing, here it is winding action, end A is fixed and this line AB is a string or a wire which gets winded over the circumference of the circle. Check here, some portion of the wire gets winded over the circle and some portion at any stage is free until the entire wire gets wound over the circle. Throughout the motion, wire remains tangent to the circle. So during this unwinding action or winding action, path traced by a point on this wire is involute. So point B has moved in this direction. If wire is wound completely over the disc, end B comes in contact with the disc. This is that curve involute. Read this example. An inextensible wire AB has length 100 mm. Its end A is fixed at a point on the rim of a fixed wheel. The wheel has diameter 40 mm. If the wire is completely wound around the rim of the wheel, draw path of end B of the wire during the winding action. Assume the wire tight throughout the motion. So throughout the motion there is tension in the wire. Okay. Now here it is an inextensible wire. So it is flexible thing and here winding action is involved. What is path traced by a point on this wire? It is an involute. Now we want to draw involute traced by end B. Draw path of end B. So let's proceed. Draw circle. So when you draw a circle, establish center of the circle first by drawing a horizontal line and a vertical line. radius 20 millimeters, take it in compass, so that you will get circle of diameter 40 millimeters. Of course, you should insert dimensions after completing the drawing. Now, during winding, wire always remain tangent. So therefore, when winding starts at that instant also, wire AB must be tangent to the circle. So draw a 100 millimeter long wire tangent to the circle. We prefer the lowest point on the circle. So this is that 100 millimeter long line AB. Divide circle in 8 parts. So this is how. At the center of the circle, measure 45 degrees using protractor. Be very careful in measurements. And divide circle in 8 parts. Now check in which direction this wire should rotate for winding action. So here, in this case, wire must rotate in anti-clockwise direction. So in anti-clockwise direction, you label these points. This is very important. Now we should divide length pi d in 8 parts. It is 126 millimeters. This length pi d is rounded because we cannot measure less than a millimeter. So it is 126 millimeter pi d is. But important thing is length of the wire to be wound around the circle can be greater than pi d, it can be less than pi d. In this case, it is less than pi d. Now, if length of the wire is exact pi d, then in one rotation, the entire wire will get winded over the circle. If length of the wire is twice pi d, that is 252 millimeters, then in 2 rotations, this wire will wound around the circle. If the length of the wire is less than pi d, in this case, then before one complete revolution, entire wire will get winded over the circle. But now you should understand the procedure. Along the wire, whatever may be the length of the wire, along the wire you measure pi d. If required, you extend that wire, but actual wire is of length AB, 100 millimeters. So only 100 millimeter length of the wire, the given wire must be dark, its extension must be thin or faint. So remember, along the wire, measure length pi d and divide that length pi d in 8 parts. You know how to divide that in 8 parts. So at end A, draw an inclined line at any convenient angle and mark 8 divisions. Each division of any convenient length, but all 8 divisions must be of same length. So mark 8 divisions. Be sure that you have marked 8 divisions, and now end of 8th division you join with end of pi d. Set roller with this line and roll the roller to transfer those 8 divisions on pi d. So use a roller carefully to draw parallel lines in this manner and continue to draw parallel lines so that you will get 8 divisions on length pi d. So label those 8 divisions now. This is initial position, that is 0th position, and now 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so length pi d we have divided in 8 equal parts. Notice here that is actually on line AB we got 6th complete part and a small portion remaining. So only 6 divisions we could accommodate on length 100 millimeters. No problem. What I want to tell you here is, if length AB, that is length of the wire, is greater than pi d, then you will get more than 8 divisions on that. Suppose length of wire is twice pi d. You will divide length pi d in 8 parts and then take this single division in compass, length of this one division in compass, and then after it you start marking again those divisions. So next division you should number not as a 9, but you should number it again as 1. And again 1, 2, 3, 4, 5, 6. That means in next length pi d you will get 8 divisions. If length, here it is 126, suppose this given length of the wire is 136, then you may get one more division. But don't label that division as 9th division, label it or start fresh as a first division, second division, and then it depends what is extra length of the wire is. So this is how you first of all mark divisions. Pi d must have 8 divisions. Now from all these points which we have marked on the circle, you are going to draw tangents. Actually, these tangents are intermediate positions of the wire during this winding action. So how to draw those tangents? Try to understand. We are going to draw tangent at point 1. Check here, diameter 7,3. Is it perpendicular to the radius C1? Yes. So take help of that. Set roller with C3, roll it and draw tangent. Similarly, set roller with vertical diameter and draw tangent. Each radius in this circle, you will find there is a diameter perpendicular to it. So set roller in this manner and draw tangent. And this is how you continue. So 6th tangent, here it is 7th tangent, and 8th tangent is here. So 8th tangent will coincide with wire AB's initial position. And now we are ready to mark intermediate positions of point B. Point B starts moving now in anti-clockwise direction so that wire gets winded over the circle. Now remember, dimensions are to be inserted after completing the drawing. Okay, now let's mark 8 intermediate positions of point B. Try to understand how to do that. Take distance 1b in compass, this distance 1b in compass, and point 1 on the circle as center. Point 1 on the circle as center, cut the first tangent. This is first position of point B. Let's label it as B1 on tangent 1, B1. And what is length of this tangent 1? Length of tangent 1 is 1b. 1b, not 1/8. Take care. 1b. Now take distance 2b in compass. And from tangent, from point 2 on the circle, you cut the second tangent. So length of the second tangent is a 2b. So label this point as B2. Similarly, third tangent has length 3b, and from point 3 cut the third tangent. So it's now very mechanical procedure. So fourth tangent is a 4b, fifth tangent has length 5b, sixth tangent has length 6b, and this is how we go on marking the points. Okay. So take distance 4b in compass, and fourth point on the circle you cut the fourth tangent, and this point is B4. Now take distance 5b in compass, and on fifth tangent mark B5. Have you noticed length of tangents is decreasing? Now sixth tangent, take distance 6b in compass, and from point 6 on the circle cut the sixth tangent. This point is B6, Label it. Have you noticed that point B, which was initially here, now gradually moving closer and closer to the circumference of the circle, and now it is very, very, very close to the circle. Let's join all these B points. From B, draw a smooth curve. These 8 points are enough actually. Of course, we didn't get 8 points. We got 6 points because wire is shorter. But in this case, try to understand. From point B, when you draw this curve does not end at B6. You will have to bring that point B in contact with the circumference of the circle. So this very, very small portion of the curve is to be drawn freehand. Just extend that curve slightly so that it comes in contact with this circle. Now if you wish, you can erase extra lengths of these tangents, but even if you don't erase those extra lengths, will do, nothing wrong in that. So this is how we have completed the curve. And now insert all dimensions and name the curve. So it is an involute. Diameter of the circle 40 mm. This is dimension line used for diameter. Dimension line is a thin line, and don't use horizontal or vertical diameter. Don't use an inclined line for dimension line for diameter. Extend it outside the circle, bend it to horizontal, and then on that horizontal portion of the dimension line, insert the diameter. Phi is standard notation for diameter. When it is full circle, you should mention diameter and not radius. Then length pi d, and also the given length of line AB. You should insert those dimensions. All dimensions are in millimeter, you must write. So this is how your drawing will appear in your drawing paper. Okay, read this problem. Draw involute of a circle of diameter 50 mm. Draw normal and tangent at a point on the curve 91 mm from the center of the circle. But again, if you remember in the last problem, length of the wire was given as 100 mm. In this case, length of the wire is not given. So what is that length we are going to use is, of course, the convenient length is pi d. So we are going to consider a wire of length pi d. So remember, in case of an involute, when it is not mentioned, length of the wire is not mentioned, then you consider it pi d. Okay, let's proceed. Draw circle of radius 25 mm as usual. Then draw the wire of length pi d 157 mm. Now here wire itself is of length pi d, and as I told you that you should divide length pi d in 8 parts, and that is what we are going to do. Now just follow the procedure. Divide circle in 8 parts. So for winding action, wire should move in anti-clockwise direction. So in anti-clockwise direction, label the points. Now divide length pi d, but here we have used length AB as pi d since it is not given in the problem. So divide length pi d in 8 parts as usual. Join end of 8th division with point B and then draw parallel lines to transfer all those 8 divisions on length pi d along the wire. Now number all these 8 points again. In this case, because we have chosen length pi d for the wire, we got exact 8 divisions on the wire AB. Do you remember in the last problem, length of the wire was less than pi d, so we got only 6 divisions on the wire. Here we got all 8 divisions on the wire. Dimensions are to be inserted after completing the drawing. Now draw 8 tangents from all these points. Draw tangents. So use roller in this way and draw the tangent. Tangent is perpendicular to radius, and that's why identify diameter which is perpendicular to particular radius and use it to draw parallel line with help of a roller. And this is how you draw tangents. This is tangent at point 7, this is tangent at point 6, and tangent at point 8 is coinciding with line AB. And now first tangent has length 1b, second tangent has length 2b, third tangent has length 3b, and so on. So take distance 1b in compass, and from first tangent get the first point B1. Then take second distance 2b in compass, and from point 2 on the circle transfer it on the second tangent. Now take distance 3b in compass, and from this point 3 transfer that distance. Now take distance 4b in compass, and from fourth point on fourth tangent transfer that distance. Now take distance 5b in compass. Just we are reducing this length of tangents by one division. So take distance 5b in compass, and from point 5 on the circle cut the fifth tangent. Now take distance 6b in compass, and from point 6 cut the sixth tangent. Take distance 7b in compass, and from seventh tangent cut the seventh tangent. And then after one complete revolution, that means this eighth point on the wire, after one complete revolution will come in contact with this point. So here that curve should end at point 8. So draw smooth freehand curve. This is how we have completed the involute. Now, we want to draw normal and tangent at a point on the curve 91 mm from the center of the circle. So first of all, take distance 91 mm in compass. And with that 91 mm distance in compass, from center of the circle, you cut the curve and label that point of intersection as Q. So this point Q is 91 mm from the center. Now wherever that point, procedure remains the same. What is that? The point where you want to draw normal and tangent, join that point with the center. So here we have joined point Q with the center. What is the length QC? 91 mm. Now get midpoint of that line. I want to tell you something important, and that is why I have taken this length 91 mm. Now you want to know midpoint. Where is midpoint of line CQ? Had it been given 90 mm, we would have measured 45 mm directly using our scale to get that midpoint. Simple. But now it's given 91 mm. So half of 91 mm is 45.5 millimeters. That cannot be measured using our drawing instruments, because least count of our drawing instrument is 1 millimeter, and therefore we'll have to use a geometrical construction to get that midpoint. And what is that? How you bisect a line, you know. Take length in compass greater than half of the length and draw intersecting arc on both sides of the line from ends of line CQ. Join these points of intersection and you have found out midpoint. Had it been given 90 mm, we would have avoided this construction. We would have directly measured 45 mm. Now as a procedure, remember, where you want to draw normal and tangent, join that point with the center and get midpoint of that line. Now midpoint as a center and line CQ as a diameter, you draw a semicircle. Line CQ, on this side of line CQ, the space is wider and the space between the curve and the circle is narrowing here. When you draw that semicircle, midpoint as center and CQ as diameter, means MQ as a radius, you are drawing a semicircle now. And this semicircle you should draw on the wider side of the space. So this semicircle intersects circle at this point. Label that point as a N. I have labeled this point as N. That suggested you that this point is going to give you normal. Join this point N with point Q. Join point N with point Q. And that is normal. And perpendicular to normal at point Q is tangent at Q. So set protractor in this manner, this straight edge of the protractor at point Q and axis of symmetry of protractor along normal, and draw the tangent. So this is how we have drawn normal and tangent to the curve. Now insert all dimensions as I told you in the last problem. Diameter here is 50 and we have chosen length of the wire equal to length pi d because length of the wire is not given in the problem. Read this problem. In a plane, line AB of length 90 mm has its end A in contact with the circumference of a fixed circle. The circle has diameter 40 mm. If the line rolls on the circumference of the circle without slipping till end B of the line touches the circumference of the circle, draw path of end A and path of end B of the line. In this case, a line is rolling on circumference of the circle, but procedure remains the same with little difference, and what it is, try to understand. Draw the circle of diameter 40 mm. And this is that line AB. Okay. Now visualize line rolling. This is rolling line. Here it is fixed circle and line rolls on the circumference of circle. Point A moves away from the circle. Point B moves closer to the circle. And it is clearly given in the problem that end B comes in contact with the circle. So we should continue this rolling of the line over the curve so that end B comes in contact. Path of end A you are asked to trace. Path of end B also you are asked to trace. So this is what, just to make you visualize what you are going to draw here or what is mentioned in the problem. And both these curves are involutes, of course. Let's construct the curve for all given dimensions. So draw horizontal, vertical, center lines, locate center, then complete the circle. Draw that line 90 mm long. Now it is not a flexible thing unlike wire. Imagine it as a rod, rigid rod which rolls on circumference of a disc. Divide circle in 8 parts. Now for rolling action, rod AB or this line AB must move in anti-clockwise direction, and therefore in anti-clockwise direction number the points on the circle. So this is how we have numbered the points on the circle. Now don't divide length of the wire or length of this line in 8 parts. How much length we divide in 8 parts? Pi d. So along this line, measure length pi d. If required, draw extension for the line, but measure length pi d and divide it in 12 parts as usual. This extension must not be dark. A circle, the line rolling on the circle, and the curve you are asked to draw. Only these lines must be dark in the diagram. all other lines must be faint line. So this is the procedure. Now you are familiar how to divide a line in 8 parts. Now all those 8 divisions on length pi d, you number. At contact point it is point 0, and end of the first division you label as 1, end of second division you label as 2. How many divisions you got on the line? Only 5 divisions. So from this you will realize that only 5 tangents are required. Of course, if you draw 8 tangents, nothing wrong in that, but it's wastage of time because 6th point is not on the wire. So before 6th tangent arrives here, point B comes in contact with the circle. So point B is in between 5 and 6. So here when point B will reach the circle, it will be in between 5 and 6. Here point B is closer to 6. So when point B comes in contact with the circle, it will be between 5 and 6 and closer to 6. So somewhere here that path of point B will end. Now as I told you, dimensions are to be inserted after completing the drawing. Now let's proceed with the proper procedure. Draw tangents at all these points. But now something new here, and what it is, listen. You should extend that tangent on both the sides of point 1. Similarly, tangents at all these points are to be extended on both the sides because there is no winding action. So here tangent at 2, it is extended on both sides of point 2. Draw tangent at point 3. Check here, it is extended on both sides. So this is how you draw tangents. I have drawn only 5 tangents. Had it been line AB slightly longer and 6 divisions on the line, we would have drawn 6th tangent also. Okay. Here it is point A, I have colored with a red color, and here it is point B. Very simple procedure and similar to what we have studied in earlier 2 problems also. Take distance 1B in compass and first tangent. Here you will get point B1. Nothing new here. But now take distance 1A also in compass. And on the first tangent, on the other side you mark A1. Have you realized point B has moved here and point A has moved away from the circumference of the circle, and A1, B1, that is first position of line AB, and here point A and point B, that is initial position of line AB. Similarly, second tangent, length 2B on one side and length 2A on the other side. Check here, take length 2B in compass, and here from point 2 you will get point B2. Now take distance 2A in compass, and from point 2 you cut the second tangent again, but on the other side. Now take distance 3B in compass, and from 3 cut the tangent on one side, and take distance 3A in compass, and from point 3 on the other side you cut the same tangent. Now take distance 4B in compass, and from 4 you will get B4 point, and take distance 4A in compass, and on the other side of tangent 4 you mark A4. Take distance 5B in compass, and from point 5 cut the fifth tangent for B5. Now point B is very close to the circumference of the circle. Now take distance 5A in compass, and the same fifth tangent on the other side you cut it. Now join these points, check here. So from point B, here point B starts and moves along this path. Up to B5 we have completed the curve. Similarly, A point starts here and these are the positions of A5. So we have traced path of point B and point A, but it's not yet over because it is clearly mentioned in the problem. line rolls on the circumference of the circle without slipping till end B of the line touches the circumference of the circle. So point B comes in contact with the circumference of the circle. So this small gap between point B and the circle, now we are going to fill it freehand. So extend that curve so that it meets the circle. So now we can say that point B is in contact with the circumference of the circle. So that point I have labeled as B dash. Now join point B dash with point C, that is the radius of the circle at B dash. Let's say this is radius of the circle at point 4. Here it is radius of the circle at point 3. Here it is radius of the circle at point 2. This inclined line is a radius of the circle at point B dash. Why this radius is required? Because at the final position also, listen, at each position, this line is tangent to the circle. Position 1, position 2, line is tangent to the circle. Position 3, line is tangent to the circle. In initial position also, line is tangent to the circle. Similarly, in the final position, that is B dash, line is tangent to the circle. So to draw that final tangent position of the line, we have drawn this radius because tangent must be perpendicular to the radius. So at this point, measure 90 degrees using protractor. Or you know how to draw tangent, you can use protractor. Axis of symmetry of protractor, you keep it on this line and straight edge of the protractor will give you this tangent. So draw this tangent. Here it is a point B now in contact with the circle. So take the entire length of the line, what is that given? 90 mm in compass, and from point B dash, here you mark A dash. What is length A dash B dash? 90. What is length AB? 90. Length A1 B1 is also 90. Length A2 B2 is also 90. Because these tangents are nothing but positions of line AB, this is final position of line AB, A dash B dash. So that means when point B moves from B5 onwards and comes in contact with the circumference of the circle, point A moves from this position to the final position. So complete the curve for point A also. These curves you can draw freehand, no problem. And with little practice, you will be able to draw smooth curve passing through all these points. So this is how we have completed the drawing. The circle, the line AB in original position, and path you are asked to draw, those two paths, path of point A and path of point B, you should make dark. Insert all dimensions as usual after completing the drawing. So, we have solved many problems on involute. So, I think you should not face any problem in constructing an involute now. In my next video, I am going to tell you how to construct helix. But before that, don't forget to like the video, subscribe my channel, and if you think you are benefited with this video, don't forget to share it with your friends. Thank you.